Thank you. Can you make the voice a little lower, please? Volume? Yes, thank you. First of all, thank you very much. I do realize this is smack in the middle of the soccer game. So right now, the score, let me refresh, is, well, halftime, 0-0. And I won't be showing you the score in the next 30 minutes, but if some of you are streaming on ESPN and you want to give out a good news, you're more than welcome to interrupt the conversation. Hopefully good news. Okay. A little bit about myself. I am the Vice President of Field Engineering for Concurrent. And prior to this, I was responsible for the big data application infrastructure for American Express. And while I was there, really can't talk a lot about the details and specifics, but it grew from its infancy to perhaps one of the largest cluster deployments in its category. As part of that, from doing POCs, evaluating a lot of technologies, took many mission-critical applications to productions on big data infrastructure, whether it was marketing, whether it was fraud, whether it was operational risk. And coming from pure product development and spending time in very, very regulated, conservative, mission-critical applications that are running based on data, whether your swipe passes or not. Do you extend a credit decision based on data or not? That's when those real-world constraints start coming in. Those were the big lessons that were learned. And those lessons were applied on the big data infrastructure, which is still evolving from what you call as growing up, participating in a real-world experience. And that's where my partnership with Cascading, which I'll be talking about today, really grew. Talking about some of those lessons. Cascading is coming out with a new version, which we'll talk about, that opens up the query planner. And what that means is that it also starts supporting the Spark platform. So my objective today is not to educate you on what is Spark. The gentleman following me is going to do a much better job talking about the internals. But my job is to talk about what is it in the real world. If you're deploying your applications, it's great to make a proof of concept. But what does it mean to make your applications operationally ready? What have other people learned? And how can you apply that? How does Cascading help you? And using something like Cascading, how can you accelerate the migration and the development of your applications on Spark? So a little bit more about ourselves. That was about me, about our company. Concurrent was started 7 or 8 years ago when the founder and the CTO, Chris Wenzel, wrote his first MapReduce program. He immediately realized that while it's a very rich programming primitive, a typical application developer does not think in mappers and reducers. Sometimes you have to go back down to MapReduce primitives, but they think in terms of a join, a filter, a function, a sort, a count, different kinds of joins perhaps, but that's how they think in terms of data manipulation primitives. Secondly, this was a growing industry, and he quickly realized that there'll be new fabrics coming out, such as Spark one day. And the applications have a longer life cycle sometimes than the technology infrastructure. So as a result of that, what he did was develop a cascading framework. Cascading is an abstraction layer that sits between your data application and your underlying computation fabric. Over the next few minutes, what I'll try to do is, first of all, take you through some of the best way to sometimes show how a real-world technology operates is by showing how multi-billion-dollar businesses have used it in big data to become successful. Then we'll go into a bit of deep dive on the cascading ecosystem, and then show how it's being opened up for Spark and what are the very obvious low-hanging use cases for real-world data applications to run on Spark. So again, I mean, new languages keep coming out, new fabrics keep coming out, new SDKs keep coming out. But what's the end goal? The end goal is that the data enterprise, that the enterprise, it's developing data products. They are running data-driven businesses. And the data-driven businesses have constraints. They have SLAs. They have regulation. They have privacy constraints. They have data integrity constraints. All of those have to be managed. It cannot be just a one-off feature you can say that it's ready for deployment. And within all of that, what we have been hearing again and again is using existing skill sets. Not only using existing skill sets, but extending the life of your investments. It is not easy to buy new storage devices every year because a new platform has come out. It's not easy to rewrite applications again and again. So it is how do you extend the life of your legacy things, as well as how do you make the best of the folks that you already have. So it's all about the data applications. The more successfully you can deploy and operationalize your applications, the better the chance of making it real and big. We talked about some of these points. So before we get into how the customers or some of our users use it, Cascading is a layer. It's a Java-based API. And what it does is it abstracts out the native computational units of work or fabrics. So instead of writing in MapReduce, you write at a higher level interface. On top of that, there are these dynamic programming languages or extensions to the cascading ecosystem. We'll be talking about that. And there are two different categories of these extensions in some ways. One are the language bindings. You can do that in Java. But Twitter uses Scalding. All of their revenue applications use Scalding, which is based on Scala. And they have actually added value if you want to do matrix math, if you want to do machine learning, predictive analytics. Scalding has additional primitives that make it more efficient to write the code. Similarly, there's Clojure, Ruby, and many other extensions too. That's one category, which is language. Pick the language of your choice and run it. The other one are the extensions, which we'll be going about, such as Pattern and Lingual too. Now, cascading. So cascading, once again. So cascading starts off being a level of, it abstracts out the lower layers, but some of the things that it's doing underneath the scenes, where it enables applications to go and be operationalized and be deployed, is because it's not just doing a syntactic or a semantic mapping to the native constructs. It's doing additional things as well. So for example, the way the query planner breaks down the units of work, you don't have to think about what if my data sets start becoming really big. You don't have to think about the size of your cluster. So there are many little nuances that enable cascading to stand up and say that when you write your applications on cascading, it is scale-free. You do not have to think about the scale of the data, the scale of your cluster. Similarly, as of right now, the big data ecosystem does not house the data natively. And what that means is most of the times, or if not all the times, the data is being created in some other system, whether it's a data warehouse, whether it's a Teradata, whether it's some other thing, and the data is brought into HDFS for processing. So the richness, the ecosystem of integration capabilities, can I move data into HDFS as part of my job? And then if I'm done, can I move the data out, whether it's going back into a BI system, whether it's going back into Elasticsearch? Those things matter. If I'm going to be spending 80% of my time writing custom adapters, then the value proposition, the end-to-end, the total cost of ownership or development, that starts to fail. Similarly, we talked about application portability. When I was at Amex and I used to come at all these conferences, my biggest need was give me a way to make my applications future-proof. I should have the ability not only to move from an Apache distribution to an Apache distribution, if required, but I want to move from one kind of analytics framework, given a use case, to another one. I should have the ability to take my application I might have written on a MapReduce framework and move it to Spark without having to do a complete rewrite. Test-driven development starts becoming very interesting as well. Now, imagine if I said, you're going to be deploying your code that you have never tested. I mean, that doesn't happen in the software world. But in data analytics world, given some of the tools that are out there, how do you test it? How do I test that not only is my script working, but is my data working? Because as I start getting incremental data, data can start getting corrupted midstream. So developing a test-driven methodology is think of data products just as software products. Do you have the tools for that? Can I get a stack trace if something goes wrong? Can I do assertions? Can I trap the data just like I would in my Java code? Those start becoming extremely important as well. And then finally, operational simplicity. Can I understand how my code is using the resources? Can I answer the question on how expensive is my join? Because if I cannot measure how my application, in the true terms, is using the resources, I cannot optimize that. I mean, that's what maturity in real world is. And getting those insights is what makes your application ready for prime time. So I don't know why I think there are a couple of slides that I hidden. Let me just go over here. Oh, no, it's coming. So cascading, as I said, it's not new. It's been around for 7+ years. There were 7,000 applications in production that are using cascading in it, over 175,000 downloads. And quickly going through that, Airbnb, for example, it uses, to prime to get the data ready so that it can be used by its Hive analyst, it has to process and do heavy lifting of lots of log files in strict SLAs every X number of hours. And cascading provides them that infrastructure to build those applications. Climate Corp has a challenge of having very complex models where you're collecting lots of signals to predict the climate for profit for farmers. And again, managing and running and scoring those models become very important as well. Twitter, all their revenue applications, all their revenue generating applications use cascading, again, for the same reason, that once you start dealing with massive scale, you need to have an infrastructure, and that's why they developed the scalding extension on top of it and added a lot of primitives to make coding for machine learning very efficient. Durkheim, what they do is they develop models that can predict if somebody's going to hurt themselves due to PTSD. Then they go and they scan the online forums and other things, and they then score the models. And the thing is, each time the model gets updated, you want to rerun those models for hundreds of thousands of the users in a very short period of time. So these are not complex, but this is heavy lifting. That's what a real world application is, and that's what they used. And the use cases, they span across all different segments. And one of the reasons for that is that if one has been a data engineer for a while, you realize that 70 to 80% of the time, it goes in preparing the data, in making sure that the data is ready for that final step of analysis. And that's why cascading has such a broad leverage across different verticals and segments. So going one level deeper, cascading is a Java API. And what it does is it provides a set of functions to manipulate the data. A set of Java functions that are platform agnostic. It's a join. It's not a map. It's not a reduce. It's a join. And cascading will take care of how it maps to a mapper and a reducer, and we'll talk about that. The second thing is, and what it does is it has a query planner, looks at your application code, and then breaks it down into smaller constructs. And I'll show you a small demo on how that looks. The second part is the scheduling. So what cascading does is the aim is to make your computation as parallel as possible. So it, in runtime, determines the dependencies between your different steps to make your application as parallel as possible, and it provides that scheduling of different jobs. And the third part is integration, that it can be easily extended. So any job will always have an input, and it's going to have an output. So you can extend, they're called the taps. So you can extend that or use one of the existing taps that are provided within the open source community. Oh, by the way, I didn't say that. So cascading is open source under Apache 2.0 license. So let me take you through an example first. Okay, let's check the score. It's halftime, of course. So what I'm going to do is I'm going to show you a visualization interface for a cascading application through the driven interface. Now, when we execute a cascading-based application, the cascading builds a state model for your application, and it transmits all that telemetry data to the server. And the server then analyzes that information, number one, during the run itself to show what your application looks like. And number two, it starts tracking the data at an application level, not at a job level, but an application level to give you insights. And that's a big difference you want to see, because I want to answer the question, how expensive is my join? I don't want to answer the question, how much did a particular job with this ID take? Because then you start losing track of the lineage. So what I'm going to do is, this is one of the historical runs. I'm going to go ahead and visualize this application. And let's go to the physical view. So this data, this view was generated from the actual run itself. Cascading has a notion of taps. Taps are input and output sources. So there could be a tap for HBase, there could be a tap, there is a tap for HBase, there is a tap for Elasticsearch, there's a tap for enterprise data warehouses, there are taps for Oracle. You can move data in and out from most of the well-known providers, and if it's not there, it's very easy to extend it. Once the tap is there, then you start defining a series of functions. In this particular case, I'm extracting the data, and it has references to the source code. And just like in a Unix pipe command, you can start stringing those functions together. Now, that is actually very intuitive in terms of how a typical data engineer operates. I'm going to get the data. I'm going to open the file. I'm going to parse the data. I'm going to take out the bad words. Then I'm going to just take the currency and the transaction date. And then I will do the roll-up. Do you see the whole notion of pipes? So it has a notion of pipes where you can connect the different steps together. And then the data can be then persisted back into a sink. So when you have execution with a source, a sink, and a series of data manipulation functions within it, it becomes a flow. It's Java code. You can trace it. You can step through it. With cascading, you can run your application in local mode with a smaller data set and then deploy it and then get the same behavior in the MapReduce with a much larger scale. And these flows can be reused. Think it's just a class at the end of the day, right? And you can have cascades on top of it. And now that's where the richness of the application comes. Let me go through the next level before we go into that. So these are the different flows for an actual execution run. At the top, what you see is a visualization of the different steps, which is I'm reading the data, I'm doing the join, and then I'm doing some manipulation. The next thing what you see is on the right, cascading takes the application level DAG, and it has an internal rules engine. It starts breaking it down into smaller and smaller expression graphs, and it's doing pattern matching till it finds a pattern that this set of operations maps to a mapper, this set of operations maps to reducer. Now that's not an easy thing to do. It took tens of millions of dollars supporting thousands of customers to come up with the right query planner. Again, it won't generate the world's best MapReduce code, but our CTO likes to say better than 80% of people who claim they can write MapReduce code. So it maps the bigger thing into smaller expression graphs, and that become your job dashboard, and these are the mappers and reducers from there. Why can't I scroll to the right? Okay, there you go. Okay. Now, for each of these, we can start tracking the number of slices, the time it took, the duration time, the amount of data that was written. So now, all of a sudden, from the top, which is your application level code, which is, well, I'm trying to do a join. I'm trying to denormalize my table. I can now see what are my bottlenecks. Where is it taking the most time? Is there parallelization happening? Do I have a skew? Is my file size distribution wrong? And those are the kind of things that make a difference between a lab experiment and a real-world application. That's what it takes to make it operational as well. So again, this was more to illustrate what you get with cascading. Let's go back. So again, in terms of source code, what does it look like? The first step is, this is a word count example. What do we do in the word count example? Open up a file, tokenize it, group it by words, and then count it. So what we're doing over here is creating tabs. The second thing what we do is we parse the data with a regex splitter, and then we use the group by function and route the data back into the WC pipe. And then we do a count on that. So what you get with cascading are these pre-built data manipulation functions. And again, over years and years of supporting mission-critical and enterprise applications, what you have is a very rich set of functionality to perform and build your data engineering applications. groups, counts, different kinds of joins depending on how your data is distributed, how you'd like to do a join. And again, this has no reference to MapReduce. This code, if the cascading infrastructure supports it, should be portable to apples to an apples computation fabric as well. And then finally, you create a flow. A flow is building a sequence of computational steps, putting input, putting output, and saying run it. And that's when you start getting all that information. Again, if you're interested in learning more about the cascading, cascading.org, there's a great impatient tutorial, definitely easy to go. We talked about the different functions that are there. It's a battle-tested framework supported by major distributions, very vibrant community, and it supports a large number of extensions as well. So getting into, this is a Spark Summit, so getting into how is it relevant to Spark. So in Cascading 3, what we have done is, remember that the screen that I showed with this application level code, and it's being mapped to mappers and reducers with small expression graphs. That's being opened up. We are decoupling that. And we are opening up the rules language that defines how does your application logic map to your native computational units. And what that means is now we have the capability to support Spark, especially something like Spark, which we are working on, because the semantic notions, the conceptual notions, they are fairly similar to MapReduce. So you may have to recompile your code, but you will not have to re-implement or change your code, and you get that portability as well. I'm going to skip this. So that's Cascading 3, opening up the query planner, then supporting different fabrics that are there. Right now we support local in-memory, MapReduce, and then we have plans to support the other ones as the market determines its pace. One of the other extensions that's on top of cascading, which is really interesting for us, and we'll try to put it all together, it is the notion of, it is lingual. Lingual is not SQL-like interface to cascading. It does not remind you of SQL. It is SQL compliant. We run compatibility tests with ANSI 92 SQL to make sure that any SQL code that's been written on another system that claims compliance can be copy-pasted and run as SQL code on cascading, getting all the benefits of running it on big data and everything. And that doesn't mean it's become an ad hoc, but what it means is I can port my workloads. And especially this starts becoming very interesting for Spark, because you think about ETL as batch-based, but a lot of the cleansing happens like looking at the lookup tables and other things, which are very iterative. That's where a lot of the time gets consumed running ETL. And Spark starts becoming a very compelling play to migrate those workloads, use SQL, and then run with that. Scalding, we talked about that. Again, extremely robust, proven interface to be developing matrix math-based applications. And then the last one is pattern. And pattern, again, is a binding that sits on top of cascading that lets you score your models on big data. You can go and train your model on R, export it as PMML, which is an XML-based standard to define a model, and then run that model at scale with all the robustness, the governance, the compliance, the battle-tested nature of the application, and run it on big data. Now, this becomes really interesting to the community over here, because with Spark, and especially those iterative models, I can take the PMML and start deploying it on Spark immediately without any significant development effort. These are the list of algos that we have implemented right now, and of course, based on engagements, we are continuing to extend that. Again, this is all open source, available through Apache 2.0 license. I'll skip this slide. What it means is train your model in an alternate system. Pattern is not for training. It is meant for scoring, because that's where the challenges of scale truly kick in. So net-net, to start summarizing it, the key points are that using pattern with Spark, you start to immediately leverage the benefits and the potential that comes with Spark, which is to use it for heavily iterative data applications. With Lingual and Spark, some of the big challenges in ETL, such as doing validation, such as doing lookups, such as doing cleansing, With lingual, I can be doing an operation where data is sitting in multiple sources, and you can still do things like federated searches and federated applications, and Spark becomes an extremely compelling use case for many ETL use cases as well. And then, of course, with scalding, that becomes very interesting because you again get a very rich set of programming primitives for matrix math and for doing predictive analytics. I showed you a little bit about the driven application. That I don't want to tout that in this talk too much, but we all, this is a developer forum. We all understand that if we have to do real work, a programming API, a programming primitive is the most productive manner to do that. But it's also known that a typical real-world application is going to last a lot longer than the time it took to develop it. It's going to be deployed. It's going to be monitored. It has to be tested for scale. Somebody else will be taking care of that, the DevOps person. You may or may not need a visualization interface to author your application, but if you cannot visualize how your application is behaving, how it's consuming the cluster, what are the bottlenecks, then you cannot improve, fine-tune, debug that application. And driven, where I gave that quick preview, that interface comes with cascading. It is free for developer use. So to summarize, cascading, we are working to supporting Spark, and we plan to announce the release date sometime very soon. It enables you to leverage all the lessons learned and the IT best practices of developing mission-critical big data applications. With Pattern, you can run scoring at scale on Spark. With Lingual, you can take existing ETL logic sitting in a data warehouse, copy-paste that code, and start doing that on Spark as well. With Scalding, you get a rich set of primitives to do predictive analytics. And of course, we are looking for contributors for the Cascading Spark implementation. So if some of you are interested in understanding how to build a query planner for Spark, and please talk to us. We'd be very happy to collaborate with you. Thank you very much. Okay, time for 1 or 2 questions. It's still half time.
Do you have a release date yet?
We haven't, the question is, do you have a release date? We haven't officially announced a release date, but we are looking at Q4 right now. And again, we are looking for contributors if somebody is interested in. Very good, thank you.
Let's thank the speaker again.
Yep.